Hi everybody, welcome to this video. So in this one we are going to start off with some simple algebraic manipulations. For instance, in this case we are given an equation 4x minus 2 equals 0, and we want to find what is the value of x, so that when it is multiplied by 4 and we take away 2 from this, the answer is 0. So to do that, we are going to follow on from some simple steps that we introduced in the video that showed how to make x the subject of an equation. So to do that, because there's a minus 2 on the left side, we have to shift it to the right side. So because it's a minus 2, we add a plus 2 to this, and whatever we do on the left side, we should also do on the right side because it's an equation. Yeah. So we do that, and the answer is 4x equals 2. Now still we wanted to find the value of x, not 4 times x. So to do that, we have to isolate x on the left side, because on the left side 4 is multiplying with x. So to isolate it, we have to do the opposite operation. So what is the opposite of multiplication? Division. I hope you guessed that. So we are going to divide both sides by 4. So that cancels the 4 on the left side and brings 4 in the denominator on the right side. So we get x equals 2 over 4. Then I think from this onwards, you're smart enough to guess 2 over 4 simplifies to x equals 1/2. So we set it out with a mission. Our mission was to find the value of x, and we have now found the value of x. Now, what is the one thing that the smart people do after they have figured out the value of x? They must verify whether the value that got was correct or not. So I'm now going to show you that. So yeah, we must always check that the value that we got, whether it was right or not. So to do that, the value that we got, which was x equals 1/2, we must substitute it back in the original equation, which was 4x minus 2 equals 0. To make it easy for you to follow, I have color coded the value. So x equals 1/2, I've colored it blue, and correspondingly I've colored x also blue. So you can easily see where the substitution occurs. So x will be replaced by 1/2. So that's what I've done. So this gives us 4 times 1/2 minus 2. As you can imagine, 1/2 multiplied by 4 gives us just 2. So 2 minus 2 equals 0. The 0 on the right side is just continuing on because we are not doing anything on the right side. But on the left side, we have got 2 minus 2, and 2 minus 2 is also 0. So that's a check, because we have got at a result that makes mathematical sense. It means the value of x that we had achieved earlier on was correct. So that means we weren't wrong. You should also do that during your exams. Okay, let's move on to a slightly trickier example. So again, we have to find the value of x, but this time you can see that it requires some extra operations. So this equation is slightly more complicated than the last one. So this time we have 2 times and in the bracket x minus 4 plus 3 times and in the bracket x plus 1, and it all still equals 0. So again, we have to act like a detective, and we have to figure out what the x value is. So the first operation that we have to do, it's called expanding out of the bracket. So if you don't know, let's watch how to do that. So first we have to expand the bracket on the left side, which is 2 times x minus 4. So how to do that? Well, the way to do that is we multiply 2, which is outside the bracket, with both the things that are inside the bracket. So first we multiply 2 by x, and then we multiply 2 by minus 4. And similarly, we have to do the same thing on the bracket on the right. So we have to multiply 3 by x, and then we have to multiply 3 by 1. And as a result, we get something like this. So as you can see, we got 2 times x became 2x, 2 times minus 4 became minus 8, 3 times x became 3x, and 3 times 1 became 3. Now what do we have to do? We have to simplify this long algebraic expression on the left side. So, and the principle for that is we collect the like terms, the terms that are similar to each other. So in this case, what are the terms that are similar to each other? I hope you can agree that the numbers are similar. So minus 8 and 3, they are numbers, so they could be added together. And then we have these 2x and 3x. They look like similar entities. In maths, x represents anything, any abstract things. For example, if I say 2 oranges plus 3 oranges, you'll say it's 5 oranges. So similarly, 2x plus 3x gives 5x. So we collect the like terms, and to make it even more obvious, I put brackets around the like terms so you can clearly see. Now on the right side, I didn't put the brackets because we already agreed the numbers are similar. But I put the numbers next to each other as well. Or if you want to still put the brackets, you can still do that as well. So 2x plus 3x and plus, and minus 8 goes in the bracket and plus 3. And then we simplify. So 2x plus 3x gives us 5x. Minus 8 plus 3 gives us minus 5, and it's equal to 0. We still haven't got to the stage where we can figure out what is x. So we still have to simplify things. So there are various ways of doing it, but one way is you can move the 5 to the right side by adding a 5, yeah. Or you can do another way. You see, there's a 5 multiplying with x, and there's a minus 5. So how about we divide the whole of the left side by 5? And whatever we do on the left, we should also do on the right, because it's an equation. So let's do it this way. So we divide both sides by 5. Now on the left side, 5 is dividing both 5x and the minus 5. So that division occurs. On the right side is just 0 over 5. So the answer to that is x minus 1, because 5x divided by 5 gave you just x, and minus 5 divided by 5 gave you minus 1. And on the right side, 0 divided by 5 just gave you 0. Now we are almost there. So we can figure out what x is, but we still have a minus 1 hanging on the left side. So we have to make x the subject of this equation, which is that we have to isolate the x on the left side. So to do that, we add 1 to both sides, because minus 1 is on the left side. The opposite of that is plus 1. And similarly, we add 1 to the right side as well. And as a result of that, the minus 1 disappears from the left side, and we get x equals 1. Now, of course, we still have to ask that whether we got it right or not. So we have to check it again. So let's bring the original equation back. So I've just copied and pasted from the last slide. And now we have got the value of x, which is 1. So we are going to substitute x equals 1 in this equation. Again, to make it easy for you to see, I've color-coded x. So I'm going to substitute x equals 1 back in this. And as a result of that, I get this thing. So you can see all the blue x's have now been replaced by the blue ones. So it's easy for you to see. And then we do the simple algebraic manipulation. So yeah, you can open the brackets again. So 2 times 1 is 2. 2 times minus 4 is minus 8. Plus 3 times 1 is 3. And plus 3 plus 1 is another 3. And then you can simply add up these numbers. And the answer will turn out to be 8 minus 8. And as you can imagine, 8 minus 8 is 0. So there's 0 on the left and 0 on the right. So we got to a mathematically valid result. This again confirms that we got the value of x correct. If you get an invalid result like 2 equals 3 or something like that coming up, then perhaps you got it wrong. So you should always check your answer before submitting it. Okay. Now, a slightly more complicated situation. So in this case, we still have to find the value of x, but now the algebraic equation also has fractions, algebraic fractions. The algebraic fractions we have covered in the previous videos. You can go back and watch them if you're not fresh with that. So here's an equation, x minus 5 over 4 minus 4 minus x over 3. Notice this minus in the middle. This minus applies to the entire fraction on the right side. This minus, some students make the mistake, they think this minus only applies to the 4. That's not correct. This minus applies to the whole thing on the right. So what can we do to start working? Well, we have to, in order to subtract or add the fractions, we should make the denominators the same. So how can we do that? Well, we have to find a common multiple, a number that appears both in the 4 times table and a 3 times table. And it has to be the smallest number possible. We call that lowest common multiple. So I hope you can work that out, that 12 is the lowest common multiple of 4 and 3. So we have to turn both the denominators into 12. So to do that, we have to carry out some work. So To turn 4 into 12, we multiplied by 3 and we divided by 3 as well. We do that because otherwise our fraction will become unbalanced. Similarly, on the right fraction, to turn this into 12, we multiplied by 4 and we divided by 4. And then we carry out. On the right side, we don't have to do anything. So as a result, we get the expressions in this form. So we get 3 times x minus 5, and the denominator we have 12 here and 12 here. So once the denominator is common, we can sort of stretch this long bar and we simply add or subtract the numerators. So we write a single common 12 underneath both the fractions, and we just simply repeat the numerators on top. So hence we get 3 times x minus 5 minus 4 times 4 minus x equals 5. Now remember, we are set out to find the value of x. We have to isolate x on the left side. That means everything that appears on the left side, we'll try to shift it on the right side. So what can we do? Well, we can't just start shifting up the numerator just yet because we have to simplify it first. But the denominator is very simple. It's just 12. So we can multiply both sides of the equation by 12. Why multiply? Because 12 is in the denominator, so it is dividing the numerator. So we multiply both sides by 12, and as a result of that, 12 just moves to the right side, so it becomes 5 times 12, and on the left side, the 12 disappears altogether. And then we continue. So we open the brackets, just like we have explained before, and the right side, 5 times 12 gives 60, and then we collect the like terms on the left side. So 3x and 4x are the like terms, minus 15, minus 16 are the like terms, they are numbers, so we add them separately. So 3x plus 4x will give us 7x, and minus 15, minus 16, these are two negative numbers, their signs are the same, so they will be added, and a minus sign will be retained. So 7x minus 31 equals 60. So we're getting there. We still haven't found our x yet. So let's continue on this slide. So 7x minus 31 equals 60. Now we have to isolate x. So minus 31 is troubling us. It needs to move to the right. So to cancel out the subtraction, we'll do an addition. So minus 31 plus 31 on the left side, and similarly a plus 31 on the right side. As a result of that, we get 7x equals 91. And the last step, we have to make the x the subject. I hope you can figure out on your own. Yes, 7 is being multiplied on the left, so we are going to divide by 7 on the left, and we are going to repeat the same operation on the right. So we get this, and eventually we get x equals 91 over 7. And of course, you can verify this by substituting the value of x back into the equation, and work it out that it is the correct answer. So I'll leave that as a personal exercise. Okay, so we are moving into the last topic of this video, which is expanding brackets when the expressions within the brackets are multiplying with each other. So we have x plus 2, the whole of it is being multiplied by x plus 4, the whole of that. So how do we do that? Well, we employ a method which my daughter calls the claw method. So what that means is we look at the first entity in the left bracket, which is an x, and we will multiply it with both the entities in the right bracket. So this x gets multiplied with x, and the next it gets multiplied by 4. So as a result of that, we get x squared, and because there after the x there's a plus, so we put a plus, and then we get 4x. Now we move to the 2 in the left bracket, but before the 2 there's a plus, so we put the plus here, and then we multiply the 2 with both the terms on the expression on the right side. So the same thing happens. 2 times x should give us 2x, and 2 times 4 gives us 8. So we put it all in the bracket. You may say, why did I put the left side on the bracket? Because, well, you can put that into bracket as well. And the elements on the 2x plus 8 is written in the brackets. And you may wonder, why is that? It's not necessary, but it would have been useful if instead of a plus, we had a minus in the middle. So in that case, it would have been useful. So next step is we sort of open the brackets. So we have x squared plus 4x and plus 2x plus 8. And next thing is we add the like terms. So notice there are three different kinds of terms here. There's the x squared, which is different from x. 4x and 2x, they are similar. They are like terms. They could be, for example, thought about 4 oranges plus 2 oranges. Yeah, but x squared is different from x, so they are not the same. And then we have a number 8, which is not the same as the previous two. So we add the like terms. So 4x plus 2x are the like terms, others are different. And as a result of that, we get x squared plus 6x plus 8. So we have opened the brackets and we have successfully managed to multiply. So that was the conclusion. That takes us to the conclusion, and I'll see you in the next one.